As you can tell, I'm not here today, but what I'd like you to do is to pull out your packets and turn it to page 10. And what we're going to do is we're going to have a little lesson up on drawing ray diagrams for concave mirrors. So turn in your packet to page 10 and observe at the very bottom of the computer screen here that for this video it has stop, pause, play functionality. So at any given time in the video, if you wish to stop or pause the video and then draw rays in your packet, you're certainly welcome to do so. We're going to learn how to draw ray diagrams, and one of the first things we need to learn are 3 rules of reflection that have to do with rays of light reflecting off of concave mirrors. So here on page 10 at the very bottom you see 3 rays of light, one of them traveling parallel to the principal axis, one of them traveling through the focal point on the way to the mirror, and the other one traveling through the center of curvature on the way to the mirror. Now these 3 rays will follow distinct laws, and the first one is that the ray of light that's traveling parallel to the principal axis will reflect and pass through the focal point. The second law is very similar to the first, only it sort of is worded oppositely. So that's the ray of light that travels through the focal point on the way to the mirror will reflect and pass, it will reflect and travel parallel to the principal axis as such. And the third rule perhaps is the oddest one of all, and that's the rule that says that a ray of light that passes through the center of curvature on the way to the mirror will reflect right back up on itself and follow the same or the opposite path upon which it approached the mirror. So at the bottom of page 10 we see those 3 rules of reflection, and we need to be able to use 2 or 3 of them in order to draw ray diagrams. So if you turn in your packet to page 11 and you look at the very top of the page, there's a case 1. We have to describe what happens if we take an object and we place it beyond the center of curvature. The question is, where will the image be formed? And we can determine that because we know the definition of an image is it's the location in space where it seems to all the observers as though the light's coming from. So just like I did for plane mirrors, whenever I had an arrow object to represent a person, I'm going to take a point on the very top of the extremity of that person, and I'm going to begin to draw light rays from that point in order to determine where they intersect, and that location of intersection is the image location. So I know 3 rules. I just have to pick 2 of them. The first rule I'm going to pick is that a ray of light that travels parallel to the principal axis will strike the mirror, it will reflect, and upon reflection it will pass through the focal point. And so I draw my first set of incident and reflected rays. Now, if I know where all the reflected rays intersect, that's the location of the image at the top of the little boy's head. So what I need to do is find another set of incident and reflected rays. I know 3 rules, so I'm going to pick my second one. I'm going to draw a ray of light that passes through the focal point. It strikes the mirror, and then it reflects parallel to the principal axis. Now you'll notice that upon reflection, it intersects with the other reflected ray right here. That's the location where it seems to observers looking along these 2 lines of sight would feel as though the light is coming from. So that's the image at the top of the little boy head. Now if I repeated the process for a point on the little boy's chin, what I would observe is that the image of the little boy's chin is right here. And if I did it for his belly button, what I would observe is that the image of his belly button would be located right about here, and his ankles right about here. And make a long story short, the entire image extends from the principal axis down to the image of his head, and I'm going to draw the image arrow right here as such. That's the image. Now the last thing we have to do in this case 1 is to state how we would describe the image. So we use the LOST principle of image description. We practice the LOST, where L stands for location, O for orientation, S for size, and T for the type of image that it is. So as I do that, what I'm going to say is that the location is located between C and F, and that's always the case whenever the object is beyond C. For orientation, I'm going to say it's upside down or inverted. For size, I'm going to say it's smaller than the actual object or reduced in size. And for type, I'm going to say real. It's the type type of image that would actually be projected onto a note card if we placed a note card at that location.